Right. Well, it's great to see everyone. My name is Deborah Yashar, and it's my distinct pleasure to welcome you to today's Global Existential Challenges seminar. I have to say, given that it's midterms, I hadn't thought about this when we scheduled. I'm particularly glad that we have such a good turnout. And again, I really want to thank our panelists for squeezing this in the context of the semester. Today's seminar is focused on global environmental challenges and opportunities. And I want to note in many ways it's a companion talk to a seminar that we had last April entitled Environmental Challenges and Sustainability, where we had 4 speakers at that on that previous panel: Joan Beal, Michael Oppenheimer, Anu Ramaswamy, and Elke Weber. They started to talk in that particular seminar on the advances and setbacks and opportunities ahead of us. They highlighted the incredible pressing needs. They talked about missed opportunities. They highlighted important advances both at the local and the international level. And they talked about the centrality of science, epistemic communities, and radical imagination, tying into work that these scholars are doing on their own, but also for work that's being done at Pierce through the Brazil Lab, through the Chadha Center for Global India, for the Fung Fellows Program, alongside work that's happening on the global stage across the university. So I'm really delighted today that we can continue this conversation a year later, but still with ongoing issues. And we have 3 terrific scholars and colleagues from the university with, again, very different disciplinary backgrounds from the natural sciences, from the social sciences, and from the humanities. Although, as I was just saying to them, all affiliated with the High Meadows Institute, which is as it should be. It's an incredibly vibrant, exciting, multidisciplinary, cutting-edge space for work on these issues. So what I'm going to do is, rather than repeat what I said a year ago, I'm going to introduce the speakers, and I'm going to let them shape the conversation going forward. First, we'll hear from Gabe Vecchi. He's the Knox Taylor Professor of Geosciences. He is also the director of the High Meadows Environmental Institute, and also the Deputy Director of the Cooperative Institute for Modeling the Earth System. His research has focused on climate science and particularly focused on extreme weather events such as hurricanes, mechanisms of precipitation, variability, and change, and focused on the ocean-atmospheric interaction, looking at detection and attribution. There are many, many publications that I could list. I will only note to highlight the productivity of our colleague that in 2024 alone, and we are only at the beginning of March, there are already 4 publications that are listed on the website, and he was this year recognized as a fellow at the American Meteorological Society. So the title of today's talk, as you can see behind me, is focused on understanding extremes and their climate connection. Next, we have Ben Bradlow. Bradlow, who's an assistant professor of sociology and international affairs, in other words, rooted both in the sociology department and at SPIA. He's also an associate faculty of the High Meadows Environmental Institute, and his research makes connections between urbanization, climate change, industrial change, and the political challenges for democracy that confront societies across the globe. His first book, which I will plug, is forthcoming. It's forthcoming still, right? Forthcoming, entitled Urban Power, Democracy and Inequality in São Paulo and Johannesburg, and it will be coming out this year with Princeton University Press. And today's talk will focus on his new research, and the talk will be entitled The Problem of Climate Change and the Analogy of Development. And then third, we have Allison Carruth, who's a professor of American Studies and again, the High Meadows Environmental Institute. And she also directs the environmental research, storytelling, and art group entitled Blue Lab. Her research and teaching area includes climate storytelling, environmental art and narrative, contemporary food movements, and the evolving relationships between technology and environmentalism in American culture. She's the author, again, of many publications, and I encourage you to go to her website, which is particularly beautiful. The imagery on that website is really striking. And she's the author, I will note, of a forthcoming book entitled Novel Ecologies. The title of her talk will be Environmental Imaginings and Impacts of Silicon Valley. So we have a full panel. We have an exciting panel ahead of us. I want to note a few logistics before I turn it over to Gabe. First of all, for those of you who are regular participants, you know that this is being taped, so just be mindful of that. Second, each person will have around 15 to 18 minutes or so. So if I'm going like this, it's both a salutation, hello, how are you doing, but also just a reminder of where we are. And then after each of them speaks, they'll come up to the table, we'll have a Q&A, and we'll go from there. So let's just give a warm welcome to this panel as Gabe Vecchi comes to start the conversation.
Well, thank you. Thank you all for being here. Thank you for having us. This is a great panel to be a part of. I'm going to approach my part of the presentation to set the physical climate basis. Imagine, for those of you who know, this could be the first report of the IPCC, and I think we'll have the second and the third for those of you in the game that come after that. I'm gonna set the stage for what are some of the environmental challenges that we are currently under, and what does that perhaps motivate. Here are two recent weather events that have a very clear climate imprint. The one on the bottom was the Pacific Northwest heat wave a few years ago, which led to unprecedented temperatures, SeaTac Airport above 100 degrees, and a lot of impacts. And then on top is the flooding or the rainfall during Hurricane Harvey in Houston in 2017, which dumped more than a season's worth of rainfall in Houston over 3 days. So the big sort of context on which we're living in is summarized here in this plot. This is the NOAA version of the global land and ocean surface temperature record. And the way this temperature record works is each bar represents a year going back to 1850. Blue bars are years in which the globally averaged, that is the whole surface of the Earth, was colder than the 20th century average, that is 1901 to 2000. What you see there is that practically all of the years before 1940 were colder than the 20th century average. And all of the years after 1977 have been warmer than the 20th century average. So one of the questions I ask in class sometimes is who was president the last time that the temperature was below the 20th century average for a year? The answer is Gerald Ford, right? So that was a year, 1976, a year that Carter got elected. So if you were born after 1976, you've never been on this planet when the temperature was less than the 20th century average. You've been living in a changed world. I've put in there, if you can read, some of the cultural and sports touchstones of each of the years. And you can see it doesn't matter who's in the office, Republican, Democrat, impeached person. The planet has continued to warm. The other thing to notice is that we last year had the warmest year on record. Now, not every year is warmer than the years before. Part of that reflects that there's natural cycles in the climate system, one of them known as the El Nino Southern Oscillation, or El Nino. And last year was an El Nino year, and that added to the warming that we've had from greenhouse gases. If we get a sequence of La Niñas, the opposite of that, we will have maybe a reduced rate of warming. So these year-to-year changes aren't what we're looking for. What we're looking for is the longer-term trend, right? So now the warming has been, last year we were a little above 2 degrees Fahrenheit warmer than 20th century average. 2 degrees Fahrenheit is perhaps not something that you would notice if it was happening here. Now, the other thing is to look at what we expect for the future. The gray line on the left-hand side over here is the 20th century temperature, or the late 20th century temperature record, smoothed with some uncertainty over it. And the future is shown by these three colored lines with different envelopes. The envelopes reflect our uncertainty in what future temperatures are going to be. You should always make statements about the past and the future, maybe even the present, with uncertainty bars. Nothing is ever fully known, but especially about the future. And as you can see, our uncertainty about the future grows over the 21st century. We are less confident of what temperatures at the end of the 21st century will be than we are what they're going to be now. And over the 21st century, the sources of uncertainty are different. Over the next few years, it's primarily the chaotic fluctuations in the climate system, things that are intrinsically unpredictable beyond a few months, that are going to determine how much warming we get. So something entirely out of our influence and control. Our inability to say how much warming we will get by the mid-20th century reflects our lack of knowledge about how the climate system works. There are some limits to our understanding and important limits. And so there are, a range of maybe a degree Celsius that we don't know how much warmer we'll get. But within everything we know, we're going to get more warming. Now, towards the end of the 20th century, we see very different, big, broader areas. And each of those lines, the central colored line, reflects a different emissions pathway, a different technological, political, social pathway. The ones that more towards the bottom, the SSP 9.9, that one reflects a very rapid decarbonization, a lot of cooperation, new technologies being brought on board and implemented. But then you have SSP 8.5, often referred to as your business as usual scenario. And that's one where decarbonization doesn't proceed at pace. So for the end of the 21st century, decisions, technological developments, things that are really hard to predict, involve people and new ideas, are really what is controlling what we don't know. The other way to view it is our choices impact the end of the 21st century, right? Now, that's all global mean temperature. None of us experience global mean temperature in any direct way, so who cares? 2 degrees, not even, my kids that complain about the thermostat would notice that. It's not the 2 degrees we're concerned about per se. What we're concerned about is the influence of those 2 degrees on things like temperature extremes, precipitation extremes, other hydrological extremes. So there are 2 main extremes that we'll think about. One are heat waves. And you can imagine cold spells acting on the opposite side of the spectrum. Temperatures on this planet tend to lie on a bell curve, like many things. And so if you shift the center of the bell curve slightly, you change very dramatically the probability of outlier events, right? So a slight shift in the mean and the mean of the distribution, which you don't really care about 70-degree days, will change the odds of 100-degree days considerably, and also it'll change the odds of cold days a lot. And that's illustrated there from historical data. You see that there's been a slight shift in global mean temperature, but the fractional change of odds in very extreme events has gone up. Now, another way that warming affects extreme events is that warming, in addition to changing temperature in the atmosphere, changes the moisture content of the atmosphere. The atmosphere can hold a lot more water vapor. And a consequence of that is that the wet extremes become more wet, but somewhat counterintuitively, the dry extremes also become more dry. That is known as a wet get wetter, dry get drier, sort of rhyming with the rich get richer, poor get poorer. And the reason the wet get wetter, it makes sense, right? Wetter atmosphere, more rain, but the dry get drier is also connected to the wetter atmosphere. And it's because the reason we have dry places on this planet is that the atmosphere moves moisture from those places to the wet places. And if the atmosphere has more holding capacity, then it can more efficiently dry the dry places. So this counterintuitive result is really easy to understand using a little bit of atmospheric understanding. So these warm extremes are expected to become more frequent. And in fact, over the last few years, we've seen many notable extreme temperature events. Here are just images from NASA for each of them. You can see last summer on the bottom right, that was temperatures in the United States in August 2023. And over a lot of the United States, you had temperatures exceeding 40 degrees Celsius. 40 degrees Celsius, if it's somewhat humid, are the types of temperatures that really put your body at risk. It's not just in the US, it's also in Europe, it's also in Africa, it's also in South America, it's also in Asia. These things are happening, and they're happening with more prevalence, and we understand why they're happening more frequently. So there is a set of people, I sometimes participate in this, where we use the technologies that we have our understanding to assess how climate change has changed the odds of extreme events. And here are 2 particular studies that were published within, or put together within days of the extreme event that happened, because it's really straightforward how to do this. one for a early spring heat wave in India and Pakistan, which we found was made 30 times more likely by climate change. This is a climate change to now, not the projected future climate change. And the Pacific Northwest heat wave was assessed to be virtually impossible without climate change. It still remains an unlikely outcome, but it goes from virtually impossible to unlikely. That's a big transition. So I think heat waves, it's fair to say that any heat wave that happens on this planet right now has at least some contribution from global warming. And that is one type of extreme event that has a clear and unambiguous connection to warming. Other types of events are a little more complicated. So our tropical cyclone rainfall. Tropical cyclones, in addition to giving you wind and storm surge, also produce a lot of rain. That is one of the deadliest pieces of it, is the water, both the fresh water and the salt water. And Hurricane Harvey was an extreme example. It just dumped water onto Houston over 3 days. Houston received more than a season's worth of rain in those 3 days. And a set of studies independently evaluated the role of the moistening of the atmosphere from warming in Harvey's rain, and found that the rainfall we got from Harvey was made twice as likely by the warming that we've had by 2017. It wasn't impossible before global warming, but it was made more likely. And these are sort of they're equivalent statements. The amplitude was made 5 to 20 times as likely. That range reflects sort of our uncertainty in certain things. Now, that is one anthropogenic, that is human-induced influence on Hurricane Harvey's rainfall. But the global warming isn't the only thing that we've been doing to the environment that is relevant. Another thing that we've done to the environment that is quite relevant to rainfall and flooding has been urbanization. Houston, for any of you that have been there, is a massive city. It's got multiple cities within it, right? There's like 3 downtowns, these massive buildings. Those buildings, as the moist winds blew in from the Gulf of Mexico, acted in a way like generators of turbulence. So that air that was blowing nice and linearly over the surface hits those buildings, starts billowing up. And what ended up happening is that those buildings concentrated Harvey's rainfall over Houston. So not only did our greenhouse gases enhance the rainfall, but our buildings, a lot of them built on fossil fuel, concentrated that rainfall over Houston. And then the paving over, the lack of a porous infiltrated surface, made that the conversion from rainfall to flood was a lot more efficient during Harvey. So the combined effect of urbanization, both through concentrating rainfall and increasing the efficiency of flood generation, increased the odds of the floods from Harvey by a factor of 20. Now, the global warming effect and the urbanization effect are not alternative effects. They're happening simultaneously, and then to some extent in Houston, due to the same reasons, right? So if these combine linearly, we're talking about anthropogenic effects at least increasing the floods of Harvey by about a factor of 40 in likelihood, right? And it's probably some nonlinearity there. If we start looking forward in time, here is a plot of the change in likelihood of a major hurricane being near a part of the coastal United States and Caribbean. Red colors indicate places where the incidence of hurricanes is greater at the end of the 21st century as the planet warms than it is more or less now. And what you can see is that over many parts of the coastal United States, the odds of a major hurricane at the end of the 21st century are somewhere between 100 to 800% higher. So that is a big increase in the odds of a major hurricane. You don't want to be near a major hurricane. For any of you want to get a real sense of what a major hurricane is like, I would point you to, there's a book called The Irma Diaries, written based on accounts of people in the British Virgin Islands as Hurricane Irma made landfall as a Category 5. Very, very sort of moving or harrowing tales there. Now, there's also some black squares in here. Those black squares are places where in our present day climate, the model says that major hurricanes are not plausible. But in the future climate, they're sort of have a finite probability. That's when systems start to break. when you have something you've never experienced, you're not built for, happening to you, right? And so, how is Portland, Maine going to handle a Cat 5 hurricane? Just think about it. Any of you have gone on vacation to a warm tropical place. Imagine what would happen if it started snowing there, right? This is the flip side of that, right? We are habituated to the climate and extremes that we get. Our buildings make sense for many of these things. In Portland, they don't, right? Now, that's a prediction for the future. What have we seen in the past? It turns out this major hurricanes in the Atlantic haven't increased, even though the planet's warmed. Here is a record of major hurricane frequency in the Atlantic over the 20th century. And it's corrected for changing observing practices. We think that we see storms better now than we did in the past. And it turns out that over the 20th century, there hasn't been an increase in major hurricanes. So the models are telling us we should expect one. But observations are telling us, even though we've had warming, that we haven't seen one. Is that a problem with our models? Should this now give us a little bit of comfort and say, whoa, these models are wrong in this way, no increase in major hurricanes? Well, in fact, the very same model now shown here in orange that tells us that over the 21st century, we should see a massive increase in major hurricanes, recovers this lack of hurricane increase over the 20th century. The 20th century has had a peculiar history that differs from what we think will happen in the 21st century. So the lack of increase in major hurricanes of the 20th century should give us no comfort, right? And in fact, we kind of understand what happened in the 20th century. So here's a set of experiments on the right asking what would the Earth look like, or major hurricanes in the Atlantic look like. In red, if we had only burned increased greenhouse gases, and you see that hurricane intensity should have increased. The black one is if we include all of the factors, and you see that you get this deep gouge carved out at the end of the 20th century that masks this increase. And what is that gouge? Well, that gouge, we think, is in part particulate pollution coming from the industrial buildup in Europe and North America following World War II, and then being removed, sort of following the clean air regulations in the middle of the 1970s or so. So we've masked this greenhouse gas-induced intensification, but now that masking is pulled off. Going forward, we expect the greenhouse gases to be dominant. But that's a prediction. We would love to be able to see it, and we would love to be able to see it in the data. Maybe I should say it a different way. So now, these types of extreme events and others, including droughts and changes in ice and snow, are really one of the things that motivates a series of responses. And these responses are broadly grouped into four types. One type is called mitigation. And what that is changing our energy sources and maybe the intensity of our energy use so as to decrease the rate at which we're pumping CO2 into the atmosphere, right? So there's another way to react to a changing climate, which is called adaptation. The climate is changing, it's going to be different. We need to change the way we live, we need to change the way we interact so as to account for that new climate. Then there is this idea that you should do carbon removal. There's an excess of carbon in the atmosphere. Let's pull it out and put it somewhere else, some geological store. And then there's these ideas that maybe what we should do is geoengineer. That is, accept that we're not going to be able to be effective with all those three things, and perhaps change the amount of sunlight that comes from the sun and actually enters the Earth system so as to cool our planet artificially. Those are our four alternative strategies, and the extent to which each of them should be pursued is I think, there can be a lot of reasoned debate on it. But I think, it's unlikely that we will stabilize climate impacts unless we pursue at least three of them together, right? It's unlikely that we will stabilize climate impacts unless we mitigate, adapt, and pull carbon out of the atmosphere. These are not alternative strategies. And in particular, climate mitigation, changing our energy infrastructure, is going to align weather with our energy supply in a way that transforms our susceptibility to weather. Fossil fuels care about the weather that occurred millions of years ago, to first approximation. Wind, solar, hydro cares about the weather now. So we are going to have to take into account that the weather and the climate that these energy systems are going to be subjected to is going to be different in the future than it is as we've been working with them. So just to summarize, greenhouse gas increases have warmed the planet, and they're going to continue to do so for decades or centuries, right? The extent to which they will do so for decades or centuries, we have some influence over. The next few decades, we don't know how much, but it's going to happen. Global warming has changed and will continue to change the odds of certain extreme events. Some of those we understand quite well, heat waves. Others we don't understand as well as we would like to. Tornadoes, to first approximation, we don't have a clue how global warming will impact tornadoes, right? Warming is already altering the odds of events. And there's a number of factors when you start getting to a fine scale, the scale of a city, in addition to global warming, that change the odds. And it's going to make a lot of our solutions, we need to think about the trade-offs, how they affect a lot of these things. The impacts of these changes are what motivates and sets the context for decarbonization and for climate adaptation. And these are not alternative strategies. These must be pursued. If we really want to stabilize climate impacts, they need to be pursued simultaneously, and they need to be pursued understanding the reality of how human beings behave, as well as having an eye for justice. Now, I'll say one final thing. I know I got the 2 minutes, and I'm going to get pulled off in a sec. But maybe I'll lay this out for those out there. Maybe we can have an argument. But I am not sure, or rather, I am sure that I am not a fan of the existential crisis framing for global warming. I'm not a fan of it because it is not factually correct in a general sense, right? I don't know for whom we're talking about or in what way. I know for small island nations it's very much an existential threat, but in what way is it meaningfully an existential threat? But more importantly, I don't think it is practically a good motivator of long-term, sustained, positive action. We need to mitigate climate if we're going to do it, climate changes, in a sustained thing. Fear doesn't get us there. Fear is good for sharp action. Fear is not good for sustained action. Not only that, there are trade-offs involved in all these things. And if something is an existential threat, how could you possibly trade off against it? So that's what I'll say. And maybe, and I hope I get some pushback on this because I'm a little too sure about myself, I think, as I said that. Maybe I'm not that sure. Anyway, thank you very much.
Well, thank you very much to everybody for coming, to Deborah and Piers for inviting me to speak today. I want to begin with an argument that's motivating some new work that I'm doing right now. And that is to understand and analyze the problem of climate change, maybe even to solve the problem of climate change. We need to understand it as a problem of industrial change. And this allows us to use well-tested tools at the heart of sociology and social science more generally to conceptualize and understand efforts to mitigate carbon emissions, and which otherwise might present some fundamental problems for analysis. So I've given you the punchline, but let's first take a step back. When we talk about climate change as a problem, what are we talking about? At the most basic level, we're talking about how human-induced greenhouse gas emissions, four-fifths of which are from carbon, are making the planet unsustainable. And this is producing powerful global social transformations. Just to summarize 3 salient examples, among many, climate change is revolutionizing patterns of migration, primarily within and across the global south, but also between the global south and global north. This explosion of climate-induced migration is ultimately an urban issue. The primary receiving areas of these migrants are the urban informal settlements of the global south. 1 in 7 humans now lives in a slum. a share that population demographers suggest will continue to rise. My forthcoming book, Urban Power, focuses on why some cities in such contexts are more effective than others in enabling a more effective distribution of public goods like housing, sanitation, and transportation. The book focuses on Sao Paulo and Johannesburg. And the consequence of these transformations is that global politics is being upended by climate change. The rise in xenophobia and racism as a structuring force in national politics is not only something shaping the rise of right-wing populism as a phenomenon of the global north, but it has fueled the rise of the authoritarian right in South Asia, Southeast Asia, Africa, and Latin America. So sociology and social science more generally can treat climate change in a few different ways. The predominant mode, at least in the mainstream of my discipline of sociology, has been to ignore it, largely. And I'm not going to diagnose all the reasons for why that might be, but a recent study found that between 2015 and 20, in two of the leading generalist journals in the discipline, less than 5% of articles had climate change as a central concern. This is changing, but then there are still some questions about what the discipline should be doing if it isn't ignoring climate change. Sociology can focus on the effects of climate change. That is essentially how to adapt to climate change, effectively treating climate change as an independent variable. Sociology can be reactive. That is, it can try to understand the social underpinnings of the problem, in essence, treating climate change itself as a dependent variable. Or social science can theorize climate change as a meta process of change that's reshaping all aspects of society. And with this framing, the overriding research question becomes, how do we get from one energy basis of economic life to another? My view is the latter approach, to treat the problem of climate change as an encompassing process of change in the energy basis of social life. But this presents difficulties for modern social science because modern social science is rooted in only one other such change, the emergence of modernity that birthed the modern social sciences. The emergence of industrial modernity has a single basis in energy, fossil fuels, the proximate human cause of climate change. So one of the so-called founders of modern sociology, Max Weber, described the endpoint, this is 120 years ago, described the endpoint of what he called the modern economic order. He wrote that this order is now bound to the technical and economic conditions of machine production, which today determine the lives of all the individuals who are born into this mechanism, not only those directly concerned with economic acquisition, with irresistible force, and perhaps it will so determine them until the last ton of fossilized coal is burnt. So 120 years after the Protestant ethic and the spirit of capitalism, have we reached the end of this modern economic order? If this is the case, then we struggle to develop a comparative logic of analysis that might help us to solve climate change. What's the right comparison for understanding change in a mode of economic life that has only one energy basis in molecules of carbon? This requires a bit of creativity. It means that we need to consider what is climate change a case of. I'm proposing that the problem of climate change is a case of switching the energy basis of social life. Post-World War II experiences of so-called developmental catch-up are increasingly seen as useful for beginning to theorize and make policy for how we get from one energy basis of economic life to another. Why are these cases useful? The structure of markets and politics and the problems of technology are all at least recognizable to our current situation today. These cases illustrate the difficulties and possibilities of changing the economic organization of a society in the context of increasingly integrated global markets. The political competition between liberal democracy and authoritarian developmentalism structures the geopolitics of global markets, and the technologies that are most clearly implicated in carbon emissions, were critical to the strategies of developmental technological upgrading for late developers. Further, developmental catch-up as an object of social scientific inquiry in the mid-20th century was largely associated with macro-level theorizing of state and society, but the post-World War II cases that I'll discuss in a moment enabled some key theoretical encounters between studies of development and the meso-level emphases of economic sociology, and this is within sociology. So the best known such cases are the authoritarian East Asian cases of Japan, South Korea, and Taiwan, and more recently in China. And two key insights from economic sociology have been wielded to explain their dramatic leaps towards manufacturing at the technological frontier and generating higher incomes. In these cases, organizational dynamics, particularly high trust, quote, embedded social ties between business elites and key bureaucrats, helped facilitate a process of orienting business towards exports. Further, iterative processes of learning by doing helped corporations to move up the technological frontier to the point where these countries are now known for producing some of the most advanced technology on the planet. But these were authoritarian cases that probably don't suit the liberal-minded political sensibilities of most American social scientists or whoever you are in this room. And what became increasingly important to many social scientists was the importance of human capital in driving development. And in fact, in the East Asian cases just mentioned, the role of high human capital was increasingly understood as a precondition for development success. But investing in welfare states came to be seen as an alternate approach to developmental catch-up. So in Kerala, a southern state in India that's larger than most countries in the world, strong links between organized labor, a political party of the left, and a political party of the left spurred increased investments in growing a welfare state, particularly in public health, which has allowed the state to become one of the wealthiest in India, effectively an upper middle income state in a lower middle income country. And in Brazil, a similar alliance of organized labor and a political party of the left enabled the country to achieve strong growth rates and remarkable drops in income inequality during the height of neoliberalism in the first decade of the 2000s. So these democratic cases have suggested that meso-level dynamics of movements and public bureaucracies allow us to see how it's possible to construct strong welfare protections in contexts where more structural accounts of global capitalism would lead us to expect otherwise. So all of these cases have the same energy source as their underpinnings, fossil fuels. But what can these cases mean for thinking about climate change as a meta process of change? What I mean by this is that social life in the Anthropocene is leading to attempts to reshape economic orders to change the energy basis of social life. And rich countries in the global north, those who preceded late developers at the technological frontier, are taking lessons from these late developers. For a while, the price mechanism predominated in public debate around climate policy, that is, to build markets for carbon. Beyond the political problems with instituting these policies, we've seen a growing recognition that purely market-based pricing is unlikely to produce technological switching points of the type required when such technologies are not mature in terms of scale and availability. The rise of green industrial policies in the US and Europe aims to build ties between public bureaucracies and private corporations that can enable goal-oriented technological shifts, and the adoption of renewable energy production and electrifying transportation are where much of this effort has gone. Now, rich countries are pursuing green industrial policies largely with no acknowledgement of two basic ironies. First, these industrial policies had increasingly fallen out of favor as rich countries pushed developing nations to open up their markets to global trade at the end of the 20th century. This coincided with increased divergence between poor and rich nations by the early 2000s. And now that rich countries are pursuing policies that protect and subsidize domestic markets to reshape the technological frontier, a big question mark remains whether they will once again, quote, kick away the ladder for poor countries to move up global value chains. Second, the majority of carbon currently warming the atmosphere beyond sustainable levels was emitted by rich countries. So their turn towards industrial policy carries little acknowledgement of the financial and moral implications of that historic legacy in trying to develop industries that can stop warming the atmosphere. And pictured here is a representation of the sources of the stock of emissions in the atmosphere. And you can see the historic stock largely comes from the global north. For countries, poor and middle-income countries in the global south have learned different lessons. First, the established path to raising incomes relies on essentially growing emissions. And this is what the global south is doing. So much so that the majority of greenhouse gas emissions today comes from these countries. And you can see this is the current source of the flows of emissions into the atmospheres, carbon emissions, largely coming from global south countries. But for countries in the global south to switch their economic trajectory to emit less, they face barriers of both finance and technological know-how. So I've begun exploring these dilemmas of finance in a new working paper with SPIA undergrad Aishwarya Swamidurai, and I explore possibilities for green technological transfers in a forthcoming article in Nature Sustainability. And these are two barriers that the global north might be able to help with. In coal-dependent middle-income countries like South Africa, a group of rich countries have come together over the past 2 years to develop what are called just energy transition partnerships. These are designed to help recipient countries to wean themselves off of high-emitting energy sources like coal and to develop new green industries. So South Africa is the furthest along in terms of implementation among the 5 countries that have negotiated these agreements. The scale of finance in South Africa is less than 1/10 of what's estimated to be South Africa's necessary funds for such a transition. And the plans to wind down coal mines are generating significant new pressure points of political anger, as represented here in a recent cover from the country's leading Business Weekly magazine. What's clear is that the political imperative is behind strategies that raise incomes. And usually that is meant to focus on growing economies, whether by emitting or not. What rich country green industrial policies are doing is suggesting that growth and reducing emissions may be possible. And this is not a crazy proposition, as this figure shows, published last year in the Financial Times. The decoupling of emissions from growth is increasingly plausible, including in some middle-income countries in the global south represented in this figure. But sociology, my discipline, has never been obsessed with growth for growth's sake. In fact, it's inequality and not growth that has defined a central axis of the discipline's research on questions of political and economic sociology. So we want to know, who is green growth for? That is, who receives the gains of green growth? We want to know who is shaping policy and firm strategy for green growth. We want to know who is doing the actual work, the labor of green growth. And we want to know the political coalitions that can sustain these models of growth. While much of the work in sociology that has addressed climate change has focused on how climate change produces or reproduces a range of social inequalities, I want to propose that an economic sociology of climate change can also shed light on questions of industrial change. First, it can do so through a focus on how market relations are transformed when the goals of interacting in markets are not measured only by prices, but by emissions or technological outputs. Second, through a focus on how transformations of markets targeting green industrial change alter economic inequalities and is aimed at producing a form of social peace. For example, US National Security Advisor Jake Sullivan has recently written and spoken about green industrial policy and its trade implications as, quote, a foreign policy for the middle class. And third, we can bring meso-level tools of analysis to understand how social resources are mobilized for collective action in institutions. And further, we can bring these same tools of economic and organizational sociology to bear on our understanding of the transnational dimensions of industrial change. Given the global inequalities of both growth and emissions, the global south is a critical part of the world in which to analyze these issues. In new field-based research in Brazil and South Africa, I've begun examining these questions by looking at efforts to transition export-oriented auto manufacturing sectors that are focused on internal combustion engine vehicles to electric vehicles when the global north is about to ban sales of combustion engine vehicles. So thank you for considering these very early reflections at the outset of a brand new project. I'll conclude by just summarizing 2 basic points that I believe this work can develop for thinking about new directions in sociology and the sociology of climate change. First, we can conceptualize the problem of climate change as a problem of the energy basis of social life. And in doing so, we can orient an economic sociology of climate change towards understanding how the meso and micro level organization of economic life shapes efforts to change the energy basis of social life. Thanks very much.
Thanks so much to Deborah for this invitation to speak about current work and be in conversation with Gabe and Ben and all of you. I should say that I think part of what my remarks will do is sort of bring the R in peers, scaling things down to a region known as Silicon Valley, but also thinking about how both its actual technological and economic material impacts and its imaginative ones have increasing planetary consequence. And then before I share these remarks, which have to do with my major area of scholarship over the last several years, I also want to mention the group I lead here at Princeton Blue Lab, because it too shares this interest and commitment to scaling down environmental and climate research and also public knowledge production to regional and local levels, particularly through an activity we call the Climate Stories Incubator. These are 4 of our public projects, and I should just mention that the one on the top left, Archival Ecologies, led and created by Dr. Jamie Collins, who's a postdoctoral scholar in High Meadows, actually deals with the very same summer that Gabe started with, the summer of 2021, taking us to an extremely local level of Lytton, British Columbia, a town that burned to the ground that July or early August, and as did much of the nearby First Nation Reserve. So that moment has been an important one for my group as well. So this is what I mean by Silicon Valley, but Silicon Valley is also a kind of symbol and story in my work as well. So what I'm going to do is share bits of a forthcoming book titled Novel Ecologies to give you a sense of how I think about Silicon Valley as increasingly crucial to interdisciplinary environmental studies around climate and climate futures. So I want to just begin with a vignette. If I close my eyes, I can still smell the intertidal marsh of the San Francisco Bay, the musky scent of reed, the rot of mud and muck. It's the year 2000. The world has rebounded from the unrealized fear that the potentially glitchy binary code powering the global economy might go haywire at the turn of the millennium. I just moved to California from Chicago, and I'm living in the terraformed town of Foster City, a place built from whole cloth on a salt marsh that the USGS first surveyed in 1892, and that was subsequently named Brewer Island. Like much of the Bayside waterfront in San Francisco to its north, the 4-mile square island has been reclaimed through leveeing, landfilling, pumping, and draining. By the early 20th century, it was, among other things, the site of a commercial dairy. In the early 60s, the Foster family reimagined and then re-engineered the island as a master plan community in the style of all things of a Polynesian paradise, complete with a 60-acre lagoon, sandy beaches, and a network of navigable canals. By the time I moved there shortly after Y2K, partly because I could not find an apartment in San Francisco during the so-called dot-com boom, Foster City and nearby San Mateo had become quintessential Silicon Valley suburbs shaped by IT manufacturing and by venture capital entrepreneurship. So today, this place I lived some 25 years ago is a nexus for big tech, whose financial and social capital is being invested increasingly in shaping environmental and climate futures around urban sustainability, biodiversity, climate mitigation, and geoengineering. I'm a scholar first and foremost of technological narratives about nature, the different forms they've taken, especially in the United States, their interplay with ecological ones, and their real-world influence on environmental movements and environmental innovations. And it's through that lens that I've been studying the rise of what I call a high-tech environmentalism emanating from Silicon Valley, and the role of this environmentalism in diverting attention from the mounting ecological and energy impacts of the tech industry itself. That work constitutes the thread of this forthcoming book I mentioned, Novel Ecologies. And in the remaining time, I just want to share a bit more from that project that I hope will be in dialogue with Gabe and Ben's remarks. So I want to start with one company and its new headquarters, Google's Bayview campus, which broke ground in 2017 and opened 5 years later. Located 20 miles, almost exactly south of Foster City, Bayview is equidistant between Apple's and Facebook's headquarters and is in the town of Mountain View. 90,000 solar panels comprise the metallic canopy roofs you're seeing here and power the, quote, all-electric net water positive buildings, which boast the largest geothermal energy system in North America, according to the engineering team. The campus also showcases biophilic design. A central atrium is called the Mothership. Corridors and common space. One thing you can count on Silicon Valley is always to love sci-fi. Corridors and common spaces are lined with plants, and exposed elevator shafts are painted with original murals inspired by California's native ecosystems, dunes, scrubs, oak savanna, and tidal/marsh, as shown here. This is more than a workplace. This is a technological utopia that aspires to be a blueprint for renewable energy, urban rewilding, and the future of work itself. Sidestepping the ecological impacts of computing, silicon wafer manufacturing gave the region its name, and Google's former headquarters sits on a Superfund site. The campus promises to breathe fresh life into the natural landscape. That vision embodies what I define as nature remade. It's a paradigm that takes up values that have long led environmentalists, and particularly environmentalists in the US, to advocate for and seek refuge in wild nature, but then assimilates those values and visions into a more technological embrace of, quote, the earth we've created. That catchphrase comes from a group of scientists and science writers affiliated with what has been termed new conservation. The science writer Emma Maris encapsulates one of the central creeds of nature remade in a book she titles Rambunctious Garden. She writes, anthropogenic climate change and other urgent environmental challenges should ignite, quote, a heretofore unthinkable, exciting, and energizing thought. We can make more nature. The technologies and tech centers that I've identified with this paradigm imagine a future in which species, ecosystems, and entire climate systems are first reimagined and then reconstructed. So one of the things that I would just note at the get-go is this paradigm does not accept any limits to understanding. So I was really thinking about how in climate science, in the different fields that make up climate science, there's a real recognition of the limits of what we can and can't know about the future, and real rigor around how we might close those gaps of limited understanding. In this paradigm, there's a sort of belief that we can know and then engineer accordingly. So however future-looking this is, though, it really draws on some longstanding national myths of wilderness and the frontier that have been especially consequential in the Western United States. And the California dream arguably grows out of those larger ideas of wilderness and frontiers, and innovation being a kind of subset there. So this is, by the way, a photograph of one of Google's data centers. It's hard to come by these photographs, and so I've been lucky that Google gave permission for me to use this one. Beneath the environmental imaginings of Silicon Valley, though, is a fast-paced, expanding infrastructure of data centers and all the network devices and network operations that run through them, also mine materials and the hardware we dispose. Now, too, AI and Bitcoin computing. In 1997, which is the year I signed up for my first email account, by the way, the total size of the internet was estimated at a terabyte. A gigabyte was considered big data, and the number of people in the world with internet access was measured in the millions. The public-facing web was mostly text-based and relatively decentralized. You might think of chat rooms here. And its energy demands were scant compared to other industries and human activities. It would be another 3 years before two Stanford graduate students named Larry Page and Sergey Brin would launch Google with just $75 million in Series A financing for their information scraping tool and search engine that they had built at Stanford. Now the size of the cloud is measured in zettabytes, which is 1 trillion gigabytes. Its energy use is thought to be approaching 20% of global consumption, a much debated figure. And the minerals, metals, and polymers used to make digital technologies of all kinds are linked to groundwater pollution, e-waste, and many other environmental challenges, both in and far beyond Silicon Valley. Meanwhile, tech companies are no longer just programming software, building computers, and operating networks. They're electric car makers and transportation providers, movie studios and news services. They are mining companies, energy utilities, and space pioneers. In turn, the planetary impacts of tech, I argue, hide behind this imaginary of the cloud, which molds how individuals, I think myself very much included, understand and experience the ever-expanding terrain of digital life, from Google search to TikTok, from Apple TV to OpenAI. So these impacts, I think, are really vital matter for environmental studies research, and particularly for my subfield known as the environmental humanities, and yet they continue to fly fairly under the radar. They've begun to be studied by researchers who are part of fields known as media studies, history of technology, and critical science and technology studies, or STS. A case in point is this brilliant book by Nicole Starosielski, The Undersea Network, which has documented an especially crucial yet very hard to see technological infrastructure, the network of undersea fiber optic cables that surface at ecologically vulnerable and culturally significant coastal sites around the world, including many small island nations. Her work has traced not just the network's history, but also ongoing contemporary conflicts that it stirs between what she calls local cultural practices and critical infrastructure. And it bears noting here that that latter term of critical infrastructure was first defined to identify the importance of undersea cables themselves to US national security and military interests in the late 20th century. So as these kinds of studies begin to illuminate, the environmental impacts of digital technologies and of tech industries are planetary, but they also have come home to roost in Silicon Valley itself. For just one illustration, as of 2022, Santa Clara County, which encompasses Silicon Valley and its hubs of Palo Alto and Mountain View, that county had more EPA-designated Superfund sites as of 2020 than any other county in the United States, 23 in total. Google, for its part, began releasing internal energy consumption and some water consumption statistics to the public as early as 2007, and the company began a fairly concerted initiative to invest in solar and wind power, to contribute in this way to climate mitigation, and to take the company itself to net zero, including its data centers. But it's also the case that big tech treats its environmental impacts as a public relations problem to manage. Consider to this point Google's logo emblazoned on its share of the Ivanpah solar electric generating system, the largest facility of its kind in the world, at least as of last year. Ivanpah was first proposed as vital to California's statewide net zero goals, but to date it's failed to deliver on that promise, having been plagued by breakdowns, fires, and high operating costs. In addition, its location in the Mojave Desert has faced opposition from both indigenous tribes and the Sierra Club, most notably, both for the lack of indigenous participation in the project and its operation, and also its potential risk to endangered species, like the keystone species, desert tortoise. So I think these forms of environmental justice and conservation opposition to tech merit the attention of researchers like myself. In particular, I think we need to find a way to both think about what tech promises as a future innovator for climate action and other forms of environmental solution making, and what it promises about its role in transforming natural systems. So in 2020, to go back to my earlier point, the internet had come to comprise 8,000 data centers and 59 zettabytes of data, and consumes somewhere around 5% of total global energy use, which is a 550% increase from 2010 alone. Some analysts see, and I've poured through a lot of this research, some analysts see energy efficiency on the horizon, but others project that the figure I just quoted will grow up to threefold in the next decade. These divergent projections are themselves important, I think. The environmental imaginings of Silicon Valley, which is also how I think about tech writ large, are popular and pervasive, but the environmental impacts of our digital world have proven very hard to track, tabulate, and forecast. The latest wave of computational and digital innovation, AI, and all that trains, builds, and powers it, offers an especially complex case study in this difficulty. AI holds the promise of being a game-changing technology for monitoring and addressing a host of urgent environmental challenges, global warming among them. And the potentially large but uncertain environmental consequences of AI have also in the last year become a subject of research and debate. I'm entering the fray of all this and beginning a new project that will delve into the environmental imaginings and impacts of AI itself through a more humanistic lens than some of the studies that have come out so far. And I welcome thoughts and feedback and questions and debates on this new area of work. But just to end on this point, for its creators and champions, AI is imbued with almost magical capacities to transform the whole world. For its critic, it's the catalyst for an existential crisis, for ecological and social apocalypse. However charismatic those kinds of technological imaginings may be, it would be my contention that they need to be held out for scrutiny, both the more utopian and the more apocalyptic ones. They need to be understood historically and culturally, and they need to be put into direct contact with the diverse lived experiences and actual consequences of the technologies Silicon Valley has dreamt up and then builds up far beyond that first view I showed you of the San Francisco Bay Area. So I will end on that note. Thanks so much.
So I want to thank our three speakers, invite them to come to the table in front. I will move down here and maybe collect a few questions, and we'll be here for another 15 minutes or so. Questions? And first, if you could introduce yourself to the panel, that would be great.
I'm Joe, and I'm just a resident here. And I think one theme that I think transcends all three of your talks is this concept of what might be called the autonomous technology. Ever since the dawn of the Industrial Revolution, the technology has been there to basically solve the problems that technology causes. And so we've essentially ceded our society to this thing we're calling the autonomous technology. And I guess the question is this, that I think the science is there clearly, but I think what is lacking is the sociological and the humanistic components. That's what we have to start developing to wean ourselves off of this concept. And I wonder if you could just comment on the ownership of our decisions, but with technology owns the things we're doing here.
Let me ask this, before we turn back to the panel, are there other questions that people want to share? Yes.
I'm just curious a little bit about the role of government, particularly, Allison, in the Silicon Valley culture that you were describing and their vision of this utopian future. There's been a lot of writing recently about the charter city movement as well, which is interesting about. And there was a little bit of tension, I think, between what you were saying then about industrial policy, which is extremely government driven, and then this idea of a Silicon Valley that exists outside the sphere of governance.
Or acts in lieu of government.
Or acts in lieu of government.
Yeah. I think these two questions could be taken together to some extent, because I think, one of the things that I would just say, and then I'll pass the mic, as it were, is right now, I think when you look back around the late 1970s, early 1980s, there were large, more traditional firms in Silicon Valley beginning to really change the economy of California and beyond that were manufacturing firms. They were Silicon wafer manufacturing firms, for example, or hardware firms. Hewlett-Packard, goes back to before the Second World War. And then there were the seeds of this new kind of firm culture that we call the startup, right? And libertarianism is so central as a philosophy in that moment to how that new Silicon Valley begins to take shape, that I think it helps explain, and this, I didn't come up in my remarks, but it comes up in other parts of this work I do. I think it helps to explain how it's not just that those startups then become behemoths, it's that they then begin to sort of operate as if governments, right, as if state actors. And so that's why I think it's so important that if Silicon Valley is, we can take it to be kind of science fictional, right? This is futuristic, this is hyperbole, this is rhetoric. But I think we would be wise to take seriously, everything from, SpaceX wanting to, colonize Mars to OpenAI, wanting to, transform all of the ways that we generate and consume language, text, imagery, and video, right? These actually have, I think, far-reaching consequences, and in fact, I think change like the sociology of environmental problems, because it means that firms, I'm going to use that term from the social sciences, are having more influence over how we address these problems in the future than state actors or NGOs.
Yeah, maybe to build off of Allison's comments, I think in a way, this is a moment where this tension is perhaps finally becoming articulated explicitly, which is that there are two different visions at stake across how do we deal with the technologies that have both caused our problems and are at our disposal. The one is Silicon Valley represents this kind of like mystification of the role of technological change, which is that it's a privately driven, individualized process. But in fact, there's a long history of state involvement in supporting Silicon Valley. In essence, Silicon Valley is a product of a hidden industrial policy in a certain sense. And now the more kind of active, muscular arm of the state in certain national contexts is suggestive of a different way that societies can present a vision for how the future of technological change should be achieved, and the kind of goal setting, particularly regarding climate change, that's pursued as a project of technological change.
So, I mean, one of the, to me, the interesting bits about the role of technology in all this is that there have been at least, so for all of human history, the environment has been a challenge for us, right? Weather events and climate events have led to mass migrations and civilizations collapsing for the history of humanity. And the recent few decades actually are characterized by a relative, even in spite of the fact that these environmental stresses are in some way getting bigger, because this technology is at our disposal. Some of the more macro impacts of these environmental challenges aren't really showing up the way they would have in the past. So there's a bit of a tension there, and I like Ben's framing. I was thinking of this as, from this energetic context, is the challenge isn't really decarbonizing. I mean, it is, decarbonizing is a challenge, but if that's all we wanted to do, it would be straightforward, right? It is decarbonizing with a vision in the future for a sort of a robust society in some sense. And this is in part perhaps why I don't like the framing as apocalyptic or existential, because it kind of, in a way, gets us off the hook from trying to articulate explicitly what is, in fact, that vision that we would like, right? It is not a carbon-free economy, period, because we had that, right? It is something else, right? And it is, in that sense, it is a harder problem to articulate because it immediately gets to values. But at the same time, it does have this technological context, right? We need, imagine a certain type of life that you would like to construct for yourself and those around you. There's an energetic requirement for that. And so you need that many watts at your disposal, and how are you going to get them? So there's a technological element, there's a values element, and they need to be discussed simultaneously. And it's uncomfortable.
So I just want to follow up on this question, and then I think Zacchaeus also has a question, because in a way, despite the very different disciplines that you came from, and the very different way that you, to use this language, sort of diagnosed what's going on, you all ended or started
That's my weekly reminder about it, teaching at 1:30.
There you go. With the importance of narrative and translating what you see into a politically actionable moment. And so I guess I want to come back to ask, how does one translate this into something that's politically actionable? Ben highlighted two examples of left-based movements that were able to do something at a particular moment by the way of growth, as opposed to, there's a commodity boom at that moment that allowed for certain things to happen. Gabe, you started off by referencing the international community and the kind of international dynamics that are happening. And obviously, Allison, you were focusing more at the local level. So I'm just wondering, huge question, but how do you translate the observations, whether about science, sociology, humanities, broadly defined, into politically actionable narratives to move forward? And I'm going to now turn to Nikias, who wants to jump in.
So thank you all three for amazing presentations. I have two questions actually, very briefly. One is actually following up on a conversation that Gabe and I had outside. I think we just heard about a question about government and bringing the state back in, to quote a very famous text. But Gabe and I were discussing sovereignties outside. And in that case, I think my comment/question connects with the key aspect of scales in climate change. And I think Gabe gave us like the lay of the land in terms of focusing on Houston, for example, but seeing from above what's happening. And that connects also with Deborah's question about the narrative. How can we actually connect these scales to create a narrative that works? Because I think that's something that Gabe and I were talking about the Amazon outside. In the end, 65 or 60% of the Amazon is in Brazilian territory, so it needs Brazilians actually to take action. It cannot come from outside. So I would love to hear your thoughts about that, and also perhaps also like treading a line between Allison's and Ben's presentation. Ben, when we talked in the past about like the case of Brazil, Brazil is clearly not following like the dreams of Silicon Valley. I would say going with a more resistant approach to electric cars, for example. And I would love to hear your thoughts about that, because when I go to Brazil, people think that Google and Amazon and Apple are the solution. However, on the political side, apparently that's not the case. So I want to hear you a little bit more about the this contradiction, I guess, between what the public thinks about innovation and what the government is pursuing.
And so the beauty is you each have a minute to answer the world's problems. And so we're going to start with you, Gabe, and then we'll go down.
So, I mean, I think how to fashion a politically actionable narrative is a massive challenge, especially how to do that and hew to the ethics that I think are essential in natural sciences. And it's something I challenge. I don't really have a pithy answer. But I do think it has to emerge from these types of conversations, and we need to recognize inherent uncertainty in a lot of the things that we do, and also that the climate system doesn't care about us, right? There are no values in the climate system nor in thermodynamics, and I think that some of and physics is cruel. In a way. So these, the world doesn't care about us.
But it's not existential.
No, but it's not existential.
I agree with Gabe on that, by the way.
In a way, the question of what is existential is relevant to the construction of narratives. And if even going back to post-war development narratives, the role of narrative was key for late developing contexts. And that's part of why I want to use these experiences to think about a more contemporary example. The one problem, and just to, I'm kind of skipping over many things, but to link to the Brazil Today question, the Brazilian government, the leadership comes from this developmentalist orientation, for sure. And so there's this idea that the state can lead a narrative construction process. But as you rightly note, the cultural purchase of Silicon Valley is not merely an American phenomenon, but this is a global projection. And so this, in a way, it presents a contradiction that makes it harder for states to generate development narratives, whether they're just about growth or whether they're about green growth or any other thing, precisely because of this kind of global projection.
Yeah, no, I agree with that. I mean, I think I will say here that in the first part of my career, I looked at the sort of technological narratives of nature that industrialization let loose in the United States in the first half of the 20th century, and specifically how that reshaped the technological, social, and cultural life of the food system in the United States, and how that then got exported. I shifted gears to looking at this more contemporary context partly because Silicon Valley and everything that emanates from it has been very effective in the last half century at creating narratives that go viral and become global, and in making its own like place-based realities invisible. I also think one of the challenges here is that narrative and climate systems, narrative and governmental systems are mismatched, because narratives, when they're most meaningful, are very localized. They're divergent even within a community. And so one of the things that I'm really interested in is a kind of experiment asking, like, how can we in fact have a lot more narratives of climate change, of how people are living it in different places, what they anticipate about the future, what they hope and fear about the future. How can we have a lot of those narratives that are very, very locally and culturally specific start to be really in contact with science and policy that happen at much larger scales? And I think we give lip service to that, but I don't think there's been any robust way in which that's happened. And that includes where people are talking about climate change when they're not talking about climate change, because for political or other reasons, they call it something else, like in the Delaware Bay erosion, for example.
Few seconds to just not only thank our panelists for an incredibly rich, exciting, important, generative set of comments. I wish we had longer to delve into each of them, but to highlight both some of the themes I think that were common across them, and then maybe just a couple of observations. The first is that obviously there's a challenge before all of us, but one of the things I want to highlight across these talks is that they highlighted that these things are unevenly experienced, and therefore we need to think about both the global dynamics, but also the ways in which they play out in the global south versus the global north, and even within the United States as an example. Incredible variation. That sense of variation to me strikes me as important. The second is the centrality of urbanization. Each of you talked about the built-up environment that ends up having these important consequences. Again, whether or not we were talking about it from a natural science perspective with the buildings and the flooding, that was fascinating too, thinking about urbanization and bends, and then a kind of suburbanization, I guess, in the context of California. Third is this question of narratives, and fourth, in terms of politics. So those are some of the general themes I want to highlight. But at a more meta level, this is what I was struck by in the final conversation. How we balance certainty and uncertainty as we think about both the science and the narratives. And I think really, Gabe, you really highlighted that, the kind of uncertainty intervals that we have as we think about what science predicts, but also those moments at which there is potentially different ways to change the way that the curve is going. So that's both an uncertainty, but potentially with a need to think about certainty on the politics side of how you translate those two different things. Second is how we think about these things. I'm going to use a language that you didn't use, as to whether or not these things are considered to be authentic or inauthentic. Again, what I mean by that is the degree to which it's true or not as people talk about that. The politics oftentimes wants us to think about certainty and authenticity, but in fact, it's much more complicated than that, so to be able to think about that going forward. And the final is, I know I said at the start, but I didn't imagine that it would be so applicable. I highlighted that the last panel really highlighted for me the importance of marrying science with epistemic communities, which is what we're talking about here, and a radical imagination as we think about how to change those pathways. Again, Gabe, you referred to mitigation, adaptation, and pulling carbon out of the air. And that's about both imagining, but combining it with those epistemic communities and the science to go forward. So thank you for being so generative. I look forward to future conversations. I want to thank you for sharing your research with us.